Earlier this morning, I updated the KEP with all of the latest changes we had discussed. Specifically, starting out with the um, IAM style authentication that we've been discussing the last few weeks. So I see some new faces here today, and some people who are back after a long time. Welcome back, Blaine. How are you doing?
Doing well, thanks. Yeah, I'm pretty glad not to have a conflicting meeting today for the first time in quite a while. Thank you.
Yeah. Um, and Yeah, and thanks for leaving the review. Um, I do want more people looking at the cap. I think it'll help make it better. Um, so so I have fixed the tab issue. You should be able to take a easy, better look at it now. Um, so I have the major change in the cap this iteration or this round of fixes from our side was about IAM style authentication, specifically talking about uh, how the user experience is going to be. I haven't gone too much in detail about how we're going to orchestrate it um, in the cozy side, because most of it is abstracted away uh, from the from the cozy system itself, from the Kubernetes side of cozy, and the responsibility primarily falls on whoever the driver is. So I've been light on those details, even though we've gone into the depths of this with GCS and AWS. Um, and in this API, as I was writing it, a few questions popped up, and I want to kind of go over them and see what you all think. So let me pull it up here, and let me go over this. So let's see. Okay, so here it is. I'm sharing my screen now. Let me find this. Okay.
Hello.
Hey, Ben.
Hey, sorry I'm late. My previous meeting ran long.
Oh, no worries. So I was just letting everyone know that I made another round of updates to the cap. And while writing the IAM part, a few questions came up. I think we might have discussed it, but I still want to bring it up just to um, make sure that it's addressed really. So this should be fine. Um, so the new names for resources, bucket still remains bucket. Bucket claim is going to be similar to uh, a PVC, persistent volume claim, as in it's someone requesting um, a bucket be created, or this claim be bound to an existing bucket. Bucket access is the object that is used to gain access to a bucket, and classes you're already familiar with. Um, we've kind of gone with naming that's congruent with how PVCs are named. Earlier, we called bucket claim as bucket request, and bucket access had a symmetric style to buckets itself, where we had a bucket access request and a bucket access. Um, from the beginning, we've kind of maintained that it might not be entirely needed. I mean, we didn't need it. Bucket access request and bucket access was redundant, and we flattened them into just one object, bucket access. Um,
But I thought that we actually did like it for the symmetry, but it was the API reviewers that pushed us to
no.
collapse it
So,
down.
well, there was no technical reason to do it, either from the user, well, not just technical, from the user's perspective, also there wasn't a good reason to keep access credentials away from the namespace where the bucket's going to be accessed. And technically either there's really no reason to do it. So we were just we were just like, why add the extra complexity? Adding more APIs is adding more maintenance burden.
Okay, it's just my opinion. I won't disagree.
Yeah. Oh, fair enough. Um, yeah, I was just trying to say that we weren't. Yeah, I'm not sure if we were uh, if we thought one was better than the other. All right. So I am style authentication here. Okay. Let me go up a little bit. Okay. So here's what I've written, and this is what we discussed. Um, so when doing IAM style authentication, we expect. Oh, it's attaching. Let me open the correct one. Yeah, there. So once the bucket is created, um, a bucket access has to be created in order to access the bucket. Where do I have that? Hold on. I think the second topic. Yeah, generating access. Yep, there it is. Okay. Oh, that's the issue. So since I've been renaming, there are some places where um, I have missed. So please bear with me. All right. So okay. So here it is. So um, here's how I've defined the bucket access in the bucket access class now. So the admin creates a bucket access class which has information about what kind of authentication type is supported by this class. Um, uh, and then other than that, the regular fields, provisional and parameters are still there. And on the bucket access side that the user will create, we specify what the name of the class, the name of the claim, and a credential secret name. This credential secret name is what will contain uh, the finally generated secret. So once Cozy goes ahead, calls the driver, and gets credentials for this bucket access, it puts the actual credentials into that secret defined in this field. Um, Now, authentication type in the bucket access class can be key or IAM, and this is what we discussed about 2 weeks back. The names themselves, that we make them key based or IAM based authentication. So we just went with key or IAM. Now, if you're doing IAM style authentication, then the bucket access class will look different. Just like I mentioned, it'll have the authentication type set to IAM, and on the bucket claim, we're going to have a credential secret name still and service account name. So the credential secret name is going to be the exact same as before. Once once keys are generated, in the previous case, once keys were generated, it would be put into this. Except in this case, we won't have any keys because we're going with IAM style authentication, where pods implicitly get privileges to access the bucket. um, but instead this will have this will be our mechanism to prevent the pod from starting up until the bucket access or provision. And also this will be a mechanism to provide information about the name of the bucket, the endpoints, and other protocol or vendor specific parameters. um, in addition to credential secret name, in case of IAM, the user would also have to supply a service account name. This service account name is going to be a Kubernetes service account, and I use that, and I say Kubernetes service account because there is another service account involved in the mix here, which is the service account on the um, object storage side. on the infrastructure side. So in Imstar Authentication, this service account and the infra providers, the object service provider service account are mapped together, such that any pod with this mapped service account can simply just access a bucket. So here's where a question popped up. I think we've brought it up before. We can only specify one service account in a pod. Um, I'm not sure uh, if we want to have, like, is this a use case that we should be concerned about? Is my question. Um, what if we have two bucket claims, uh, or two bucket accesses? Should be called bucket access. Yeah. So two bucket accesses, um, and both, and you want both these bucket access, or you want access to two buckets in a pod, and each one of them points to a different service account, or you can't have them point to the same service account. Is that a possibility?
Sorry, you would want them to point to the same service account, right? Because the understanding is the pod is going to have a service account, and any bucket access that has a different service account won't work.
Yeah. So the
That's
issue
the
I
whole
see
problem.
with it.
So,
Mhm.
and that's true whether you have one or two or three or whatever number.
It's easy to make service account kind of super privileged this way, isn't it?
To make them what?
Like super admins, like very highly privileged, like they get to do much more than, like one service account is going to have just a lot of
Yeah, I mean,
access to a lot of information.
service
Is that
accounts can be as powerful or as not powerful as you want.
more along the lines of, what if I want to revoke only one part of the access? That can still be done, right? Yeah, that can still be done. I was just
Revoke
wondering if there
access to buckets or to other
either
things.
either any of them.
I don't see how that's relevant. I mean,
Yeah, I know,
the
I know what you mean.
the whole point of IAM is like you already have a service account that you're using, and you just want to use the credentials that you already have to authenticate to your bucket. So like at that point, anything else the service account is being used for isn't relevant to us. It's just that, hey, I already have the service account. I want to use it to access my bucket. Please give me a mechanism to do that. And the mechanism is create a bucket access that points to your bucket and has the same service account that your pod's going to have. And that's our job. And then whatever else you do with your service account is on you. And in theory, lots and lots of bucket accesses are very cheap, right? So you could have a handful of buckets and a handful of pods, and they could all be using different service accounts. And so now you have to create a huge number of bucket accesses, but who cares? Because they're just lightweight objects that represent an access being granted to a bucket from a service account.
And when are we still declarative, as in, is there a dependency on service account already existing, and is that a problem? Let me That's what I want to.
Yeah, I think we said that if you create a bucket access that points to a non-existent service account, it'll just sit there, right? Because there's nothing for us to do. The sidecar will see that. It will attempt to look up the information for the service account so it can invoke the Cozy plugin, and it'll say, oh, I can't find anything here, and it'll just go into a retry loop.
Yeah, that seems logic. That seems reasonable. Um, yeah, I'm just making sure we address everything. So I'm just bringing up these questions. Um, so would you say that we check if service account or credentials, service account exists before we even start orchestrating with the driver?
Yeah. I mean, because the sidecar has to pass the details of the service account down to Cozy
Fair
or
enough.
down to the RPC, gRPC. Like we can't make that call till we've pulled in the relevant details. And if the relevant details don't exist, we're stuck.
It's just by name. It's really just by name. Um,
No, it's
tokens are not exchange, is it? I'm.
it,
It has to be.
like if it's GKE and you want like a Google credential, like we're going to be handed the Kubernetes credential. We're going to have to go do whatever the relevant thing is to map that Kubernetes service account to a Google service account before we pass that down to the RPC, right?
Mhm.
So, I mean,
Wait, sorry, Ben, what do you mean by we? Who is
the
we?
the cozy sidecar, right? The cozy sidecar that we write has to, and the thing that's watching bucket accesses and reacting to them is gonna,
I
that's
guess,
the glue, that's the glue between the Kubernetes object and the cozy gRPC is
but
our sidecar.
shouldn't that be the job of the driver? Because I feel like, like Google IAM is like a Google specific thing that the Google driver should do. Not the generic one that's supposed to be like implementation agnostic.
Right, but the mechanism by which Kubernetes service accounts get bound to, cloud provider specific service accounts is itself generic, isn't it? Like if it isn't, then you're right. We're stuck.
Like I kind of feel like it shouldn't be the job of our sidecars to understand cloud specific things. Like they should.
Right. I agree with that. I what I was presuming is that there was a generic way that regardless of which cloud you're in, that given a Kubernetes service account, you could look up the appropriate other service account information. And if that
I'm
is not the
not.
case, then you're right. We just have to say, okay, here's the Kubernetes service account. But we could still do an existence check before
Mhm.
calling the gRPC.
Yeah,
right?
I'm not sure. I'm not sure if there's a way to like a provider agnostic way to like translate the service account.
You mean other than by passing the token? We can always just pass the token and possibly even the name. That's all is there to a service account. It should
Well,
work.
service accounts can have many tokens over their lifetimes.
Oh,
Right.
right. Oh, yes. Now I
So
remember.
the service account gets created and it initially gets a token, but there's no guarantee the token will be the same tomorrow.
Yeah, I'm thinking it. I'm not actually. I haven't looked on like a cluster to actually see how the cloud specific service account is stored, but I would guess it's. I would guess it's not a generic way.
Mhm. I think you're right. Um, and even if the current clouds, all the object storage providers do it in one specific way, there's no guarantee the next one's going to follow that. So I think I think I think it's better to leave it up to the drivers, unless there's a concern with that also. The drivers will be. Mhm.
Yeah, I'm cool with leaving it to the driver.
Well,
Again,
well,
it
mhm,
so someone who knows the details should tell us what the appropriate thing is.
right.
I guess I was just responding to the service account must exist, and
Mhm.
regardless of whether the details of how service accounts, Kubernetes service accounts get bound to, for example, a Google service account, I still think the sidecar would want to validate that there is a Kubernetes service account with the given name before passing it down to the gRPC,
Yeah.
right? And it could just say
Mhm.
no.
Yeah. Yeah, that should work. All right. So the next question was going to be around. So I do want to discuss reference policy, but before that, I'm just thinking through and seeing if there was something else left over in the service account thing. Um, so yeah, this is going to be straightforward. So once we map the service account to an object storage service account, or a cloud service account, someone can just specify it in their pod, and just like that they have access to the bucket, and they'll know the details of the bucket itself by looking at the credential secret that's mounted at a path of their choosing. um, oh yeah, this is what I wanted to go over in this itself. So bucketinfo.json. um, so in case of regular key based authentication type is going to be set to key. So bucketinfo.json is the file that gets mounted into the pod with information about how to access the bucket. So it's going to have fields that are required for this purpose. So so in this case, I've put out a sample bucket info here, and in case of key-based authentication, it's going to be key, and in case of IAM style authentication, it's going to be IAM. In key-based authentication, it's pretty straightforward. You just have the access key and secret key. In IAM style authentication, um, I've put this in there, the metadata URL and the service account token path. Um, the idea behind the metadata URL is that's the client SDKs, or pretty much all of the object storage client SDKs utilize a metadata URL, or talk to a metadata service of some sort to figure out uh, or to exchange their service account token for a token that can be used to get access to the bucket. So my uh, one is, you can assume that the client SDKs know how to do this, and you don't have to specify the metadata URL. But specifying it allows, gives us greater flexibility. So my question is really, any thoughts on that? Anyone knows more about this than I do? Anyone who's worked with metadata service?
Yeah, I think I had made a similar suggestion earlier on, mostly just because it gives implementers flexibility to invent something else
Mhm.
and have the scheme still work. But I think the argument at the time was, well, is anyone actually going to do that? And the answer is probably not. So I don't have a strong feeling.
Okay.
It's just, I do think it gives us another lever to pull if we want to do it differently in the future.
Yeah. Except as I say this, even though I was on who added it, I'm wondering now, is it better to add it when needed rather than to just have an extra thing?
Not if you want it to be backwards compatible. I mean, either we force
How
people to
do you
start
think?
using it from the beginning, or we leave it out and then we never add it, right? Because backwards compatibility means adding new required fields breaks everyone when you add them.
It's not a new required field though, right? It's a new
Well,
optional field.
Right.
it would be required for workloads to consume it, right? Our biggest portability concern of all is that we want workloads that are written against Cozy 1.0 to work forever, no matter how many changes we make to the API or the underlying implementation. The workloads themselves that worked in the first version should continue to work in the second version, and the third version, and the fourth version as we improve things. Other
Yeah, so I
things
think
can
existing workloads will continue to work, right? And it's
well,
only
but
the
if we're
newer
passing
workloads that need this new field that would need to change.
but if we're passing it down to say, like, this is where you get your metadata, and a workload is currently assuming that it's in a certain place, then if in the future we're like, oh, we're going to change the place where it is to this other place, and then it's only available in that new place, then the old workload that was making the assumption about where it was is not going to read the field. It's going to go look in the place where it assumed it was. It's not going to be there, and it's going to break.
Yeah.
So
No,
the
but I
safe
think
thing to do is to require it from the beginning and say, look, we're always going to tell you where it is. And maybe that value never changes, but if it ever does change, at least you're reading it and looking there.
I guess though, like if say you're using something like S3 SDK or something, is the metadata URL actually configurable? Is
But
that
yeah,
something you would pass in?
Yeah,
that was
yeah.
going to be
So
the flip side argument is if it's not even configurable, then of course we can't do it because the capability isn't even there to override it.
so S3
Yeah, like I
support.
think, sorry, I think my basic argument is I don't think we should add an API field for something that is not going to be used right now, because like we don't know if when we actually need it, is the format gonna be the format we need.
That too. Yeah,
Well,
that's a good
well,
point.
I agree with half of that. Obviously, we shouldn't add a field that we can't use right now. But I would also argue that if we can't use it right now, we can never add it, because to do so would be to break the backwards compatibility.
I don't agree with that. I don't think adding the new field will break backwards compatibility.
No, I think where Ben is coming from is it's a new field for an existing workflow. So the same thing that you could do without that field now requires that field. So the meaning of the workflow or the workflow itself changes.
I
That's
don't
what.
think so. Like if say you're using the S3 SDK right now and you're not using this field, even if we add the field in the future, you will still be ignoring the field and it will still work.
Well,
Yeah. So the
if we
concern is.
ensure that the change is that the other change is backwards compatible, but then it's not a new required field; it's a new optional field. It's a new field that's
Yes.
safe to ignore. So
Yes.
that's the key: is anything we add is going to be optional, and therefore all of the required stuff we have to have in on day one.
Yes.
Okay, so we agree on that.
But aren't we telling our users you can safely ignore this field and it'll work, say for S3, while you know so
So
it might
I guess
work for the official SDK. Sorry, go ahead, Michelle.
oh yeah, like let's pretend like there's actually an SDK where this is required. And
Right.
if we don't include this field right now, if you try to use that SDK, it's not going to work. And so, then we'll be like, hey, to support this SDK, we need to add this field. And so we'll add this field, and then users of that SDK can start using the new field. But like they were already broken before, right? So adding this new field won't, break them even more.
Well, they were unsupported before, and
Mm-hmm.
now we say it's supported now. Except we also have to, I mean, I guess if we also communicate and say that in order to use this new vendor that has a different metadata URL, you'll also have to use a different SDK, and so we're not really drag and drop replacement um, between different vendors at that point, because the application will need to change uh, the SDK as well as the definition in the cozy objects.
Yes, but I think that's kind of I don't see a good way around that.
Mhm. Fair enough. I think
If
that's
like
okay.
if the current SDK like doesn't even use this field and it's not configurable, and if you need to use a different object storage vendor that requires a different SDK, I mean, I think there's not a good way around that.
Fair enough. Yeah, that's kind of why I brought this up. So it seems like we're all in agreement that this field isn't required right now, and we can add it going forward if needed.
I mean, my hope is that we settle on an interface that contains all the information that we need, and then things like things that anyone could in principle need, and then we deal with impedance mismatches between what Cozy is able to provide and what an SDK wants through the use of stuff like init containers that would go and read files and write other files and just sort out the details. Because at the end of the day, Cozy's not going to say like, we're compatible with SDKs A, B, and C.
Right.
We want to say like, what Cozy gives you is this file at this path with these contents, and this is what they mean. And if your SDK can just read that, great. But if not, you have work to do. And I would rather that that's the kind of statement we make is that, you know, Cozy is providing the following JSON file in the following place with the following fields. And maybe you need to go access an HTTP API, in which case the protocol is as follows, you know, and we spell it out. And then hopefully SDKs can just work with that, but it's not our job to keep the SDKs up to date or make them compatible. It's just, you know, our job is to provide the same information down into the workload every single time.
Yeah, agreed 100%. All right, so yeah, so there's another field, the service account token path, that I added it because I wasn't sure at that point if we ever as in if you're going to choose a particular token and kind of specify it in the bucketinfo.json to say that this token is the one that's going to give you access to the bucket, is I don't know if that's even possible or realistic at this point. um, the idea behind it was, in case you couldn't specify the service account name, because at that point I still wasn't sure. In case you couldn't specify the service account name, and you directly then you could directly just use have credentials be granted, or access be granted for a different service account, and just have the token mounted in this path here. That was kind of another thought that I had. So if I were to have a service account token uh, mounted at a different path, then I'd have to provide the path here, so that client SDKs can read from that path and then use the metadata URL, the default one, to
It seems to defeat the purpose of IAM authentication to be like putting second or third service account tokens into the pod.
um,
I don't understand when that's a win relative to just granting access to the service account that the pod is running as.
yeah, it doesn't make sense anymore because there's just no need to have multiple service accounts. So I think we can take that out. It sort of made sense when we had or when there was a possibility of requiring two different service accounts mounted into the same pod. But at that point, I also wasn't considering the fact that we can have multiple tokens per service account. So
Well, not at one time, I don't think. Just across
um,
time, it can rotate. That's my understanding. Please tell me if I'm wrong.
so
And,
as soon as you said it, I remembered it. Let's just quickly look it up.
and the path will be constant, right? Even if the token is changing. Like,
Yeah, and it won't change over the lifetime of a pod. So like if the token rotates underneath the pod will continue to use the old one, I think.
Okay, that's fine. Type, for some reason, in this Chrome profile of mine, I Control F doesn't work, but in this other profile it works. I don't know the configuration that does that. So all right, it has a bunch of secrets. That's all it is. Okay. So it's multiple tokens. I just wanted to verify, even if it's just for me, just for understanding it better. Coming back here. All right. So this is where so this is what I'm going to update the kep with then. I'm going to take out metadata URL and service account token path, which yeah, doesn't even make sense anymore. So the next thing is I want to talk about bucket sharing. So in alpha, first I want to confirm this. In alpha, which is our next milestone, we are saying that buckets created in one namespace is freely shared with others, or with other namespaces. That's the kind of stance that's how we're starting out with this. um, and the reason for it is we're still flushing out the idea of how to restrict access, and the best plan we have right now, or best alternative we have right now to this, is a reference policy, using reference policy. uh, and reference policy is where you get to set a policy that defines what can you refer to from a particular resource. So so for instance, you could say, um, from this namespace, a user can only refer to buckets, specific buckets, and but not all of them. um, Reference policy lets you specify that. So we're still flushing it out. Like that's kind of the approach the gateway API team is following, and we've been encouraged to go look at it, and that's how it works with for them. And I think we can adopt something similar here. um, but I wanted to first confirm if that stands for alpha is what we indeed decided on um, long back when we last discussed it, where bucket is can be freely shared, and in the future we're going to move to reference policy. Any
Yeah,
thoughts or objections to that?
I think it's a bit concerning from a security perspective. Like anyone in the cluster can access your bucket and your data.
Mhm.
well, the problem was
Yeah,
that we know we need a security mechanism, and we went through several different ideas, all of which got rejected, and the least bad one was the reference policy, which we liked. But I think is it a timing issue, Sid, that we can't get the reference policy stuff in the alpha, so we were going to just say, well, this is coming as part of the alpha 2 or beta or whatever.
Right. There were enough concerns to address based on feedback with just alpha. And just in terms of timing, yeah, it's a timing issue. We
I
we
mean,
can't address all of it.
I guess for alpha, can we restrict our like use cases initially to say like, the bucket is only accessible within a single namespace, and then
That is also
open
fine.
it up with the reference policy.
What if the namespace which originally created the bucket gets deleted?
Well, no, I think the issue would be that in the alpha, then there'd be no way to share buckets across namespaces.
Yeah, that's my
Period.
suggestion.
Yeah,
Like
yeah.
for like the alpha, restrict our use cases while we're
Because
waiting for this
just to
reference
start with the
policy.
more restricted and expand rather than start with the expanded and then restrict. That's the
Yeah.
argument. I can see that.
But we're not really restricting, as in we're not really saying you can't do that. We're just saying you have to do that with the policy now. Um, I mean, it's alpha. It's understood that things will change, um, and I think saying no reference, sorry, no sharing at all, uh, is it is probably less desirable than saying anyone in my cluster can just access the bucket.
Well,
The one
if what we're
security
trying to
mechanism.
say is like, here's the proof of concept, please go out and use this and tell us what you like and don't like about it.
Mhm.
As a user, I would rather be in a situation where like I can use it securely and it's missing some features than be in a position where it has the features, but it's not secured yet.
I mean,
Like,
isn't the other side of the argument going to be, well, I can't share at all now?
right. But I mean, there's a huge number of use cases that just don't involve sharing. So we'll at least get people to test those and give us feedback on those. And then the sharing ones will become enabled once we have a formalized mechanism for sharing. So
Yeah, I'm fine with that.
I guess I'm on board with what Michelle is saying. Like, start with the secure thing and expand by adding sharing once you have a way to do it securely.
Yeah, or start without the insecure things. Yeah, I'm fine with that. Either stances are okay. So it does raise a few questions though. What happens to a bucket when the namespace that originally created it, and that kind of, now there's this concept of ownership, like the namespace that originally created the bucket is gone, the namespace itself is gone, so nobody can.
I forget, did we have a use case for importing an existing bucket?
Yeah, we do.
So
Well,
would
you
that
can
sort
always
of be used? Like when you delete the bucket, you actually don't delete it, you retain it, and then you can import it into a different namespace in the future.
Yeah.
there's that, and there's
In the
also just
future.
the rebinding of the bucket object, right?
Yeah. So I think what Michelle's saying is similar to what you mean by rebinding pen. Importing of an existing bucket, when we say that, we generally mean importing a bucket that was created outside of Cozy, something that's already there but not in the cluster yet.
So it's
In
similar
this
to
case,
the PVPVC behavior, right? Is that what I mean? Kind of like you have a volume before you import it. Just similar to the PVPVC static provisioning case. So in this case, the static provision of the bucket.
Yeah, although mechanically it's probably more similar to pre-existing snapshots and importing a snapshot, like the static snapshot case. But yeah, either way, you could either just delete all the Kubernetes objects using the appropriate retention policy so the actual bucket doesn't go away and then fully import it, or you can get someone with appropriate power in the Kubernetes cluster to just rebind your bucket to a BR in a different namespace and fix it up that way.
can you change retention policy after? Yeah, this is another thing. Can you
It
change
should
retention
be
policy after the
that
bucket
should
is
be
created?
yes.
Yes.
Retention policy can be changed.
For all other storage objects you can, so I would recommend we do it too. But
Yeah.
more specifically, like unless we write an emission webhook that prevents them, like you can do anything. So the only things that will be prevented are what we explicitly prevent in our webhook.
All right. So if we were to do this rebinding thing, that's kind of like there needs to be a bucket claim in that new namespace, right?
Yeah.
Right. Similar to PVPVC in that case.
So in case of this rebinding use case or rebinding way of doing things, there is a manual admin step that is involved. I mean, it's temporary until reference policy comes up.
Yeah. So the point is, it can be done before we have proper sharing.
Okay.
And we can write down how to do it, and it can be gross because it's alpha.
Okay. Sounds good to me. So just to summarize, we're saying that right now the way we do bucket sharing is, well, we don't do bucket sharing. It's really not accessible by two namespaces at once. But if the but the
Wait a
bucket
second.
can be
I thought
kind of.
I thought that should be possible, right? You just need to have two bucket API objects pointing to the same. So it's similarly to snapshots, because snapshot you can share that way. It's just
So
we don't provide a API for you to do that, basically, like the what is that reference policy? We don't provide that, but you can actually do this manually by creating a new bucket API object pointing to that bucket. You should be able to and then you have
Right,
a
right,
bucket
yeah,
claim, right? So
that is true. Yes, you can still do that. You can manually create a bucket object while the other bucket object is existing, and have that new bucket object point to the same backend bucket in the object storage provider, and now you can create a bucket claim that binds to that new bucket. Yes, that is possible. That is still that is still possible, and I don't know if we should prevent that. I don't know if we
but
can prevent
why
that.
do we want to prevent that? The
The security.
security issue?
Mhm, that
It-
Michelle was bringing up.
But Michelle, is that what you mean? I thought if it's a way to statically provision, then that should be allowed.
Yeah, if it's
Yeah,
an admin doing it, I think we can say, admin can do whatever they want.
Right.
Yeah. Okay. So we do have this concept of ownership, and then kind of, I mean, we don't want to say it that way, I think, because it's not going to be relevant right after alpha. But we kind of do, where bucket is owned by a namespace until it's not.
I guess one interesting question I have in general about the sharing use case is like we're tying things to service accounts, but like pods in different namespaces are going to have different service accounts.
Oh, so we have the concept of creating or binding a bucket, and that's separate from accessing the bucket. The service accounts are tied to bucket access objects, which are namespaced. So if
Okay,
you,
so you can
yeah,
have multiple bucket accesses to the same
mhm,
bucket.
yeah, yeah. But currently, we're going to only allow multiple bucket accesses for the same bucket from the same namespace where the bucket was claimed. Where from the same namespace where which triggered the creation of the bucket. So this also adds another concern, which is what if you're exporting a bucket that wasn't created in any namespace? Who gets to be the owner of this bucket? Let's say I have two different bucket claims from two different namespaces, trying to bind to this bucket. It's kind of it's a race condition at that point. So is that
Does the bucket object have a like back pointer to the
Mhm.
bucket claim?
Yeah.
Yeah, so I think at that point the admin decides which namespace gets to own it.
yeah. If you set up a legitimate race, somebody will win it unambiguously, and they'll be the owner. If you don't try to make a race, then you can arrange for the winner up, ahead of time.
Mhm. Okay, I think for alpha that's okay. Again, this won't matter as soon as we do the reference policy thing. So yeah, it's fine. Yeah, so please take a look at the cap, and um, I'll make the small updates needed to just catch up to everything we talked about today. But other than that, I think it's ready for another review. Um, and if anyone here has any questions, now's a good time to bring it up.
I actually had a question on sort of the node level design.
Mhm.
So my understanding is we have like a node plugin that's actually mounting a volume with the information like the credentials and stuff, access tokens into the
We
pod.
mhm. We got rid of that, so we don't have that anymore. We originally had it just for only one reason, which was to prevent the pod from starting up until the credentials were ready. There was always another school of thought about that, which is just use a secret. because secrets also do that. We finally ended up moving over to secrets. We don't
Oh,
have that
okay.
node agent.
Do you have a place in the cap that kind of shows how like the access tokens get injected into the containers, the pod?
Right. Yes. That would be this time I've called it attaching buckets. Um, it's not the same as attaching a block device, but I've just used the term attaching. Maybe if someone knows a better word, we can use that here. I've just called it attaching buckets, and yeah, it talks in detail about how to go about doing that.
Oh, okay. So basically the pod needs to add this secret volume mount to their spec.
Mhm.
Okay, cool.
Yeah,
And
in
yeah,
case of
because I
IAM,
remember at least there was some early design where there was like a CSI driver and stuff.
mhm.
And so you're saying all of that is gone?
Yeah. We actually implemented it even, and it's unnecessary again, just technically speaking. And the one argument for it was, what if we what if the secret um, already exists? So in this case, there's a possibility of a user wrongly specifying the same secret name for two different bucket accesses. So the user might choose a secret name, secret one for bucket one, and as well as bucket two. And in this case, depending on the order of creation, one of the buckets, the access will be granted for one of them, but not both. With the node agent, we could auto generate these secrets, have them have random names, and the user would never have to know. And this the secret would be mounted into the pod. We would don't eventually put it in the kubelet, but again, the argument against that was the user should just know that they're using the wrong secret here. It's a user error at that
Yeah.
point.
I mean, you could mitigate that by setting the RBAC. Well, I guess RBAC is at the,
Namespace level.
yeah, but you could set a role binding to like a specific service account, and it could be like this service account is only allowed to access like this one secret instead of,
Yeah, we
allowing
can't
that
do that.
service account to like access all secrets in the namespace.
Yeah, I mean, if we, yeah, that's the one issue I see. I see that as a major issue in all of Kubernetes, really, because we can't have that level. We don't have that level of granularity. I think I might be wrong about this. Last
You
I
can't. You can set roles. You can set roles on specific objects.
Oh,
So you can
really?
say
Huh.
like, yeah. You can create a role that's like, reader secret foo, and the role could be like get access to secrets resource name foo.
Michelle, I think the problem that Sid is alluding to is that when you're running as a controller, you don't necessarily know which user created each individual object. So like, unless you have additional information about which service account or which user is supposed to have access to something, like in the context of a controller, you
You mean
don't
the
know who.
controller that's granting the access?
Yeah.
I think you have the bucket access, you need to pass in a service account, right?
Right.
So
So in the case of a bucket access, we explicitly added it, but like in the general case, you don't always know who created what. Like you don't know who the owner of a bucket is. It's just an object in a namespace with no user information associated with it.
but I guess that's why we need the bucket access, right? Because I guess by default you create a bucket, but no one can actually access it until you create the bucket access object.
Right.
Mhm. But anyway, so yeah, we got rid of the node agent, and we said that the user has to use it correctly. And I mean, if we can also, I don't know if we can use reference policy here, but that's we're almost out of time, so we can continue that discussion next week.
Cool. Yeah, sounds good to me. I know maybe some food for thought for the next discussion, but I know in RBAC, there is this general concept of privilege escalation, which is like basically being able to grant yourself permission that you don't have. It might be good to run through the thought exercise to see if the bucket access object could have a similar issue.
Oh, you mean RBAC rules can allow access
Like
to
there's,
RBAC
yeah,
access?
like there's this like issue scenario where it's like, if you have permissions to create roles and role bindings, could you actually create a role binding to some resource that you actually don't have permissions to? That's like a privilege escalation problem, and it's something that our RBAC system actually detects and prevents. But it's like special logic that has to be implemented. And so I'm wondering, since like, bucket access is like kind of similar to RBAC. So we should think through and see if it's possible.
We can address that with reference policy, saying that bucket access can only.
Yeah, but anyone in that namespace who can modify or create bucket reference policies can also just create a new one of those. I think our security model has been, if you have a bucket in your namespace, you can and you can create bucket access in the namespace, you can in principle grant access to anyone in the namespace. Maybe we need to like validate that the service account being referred to is in the same namespace. I mean, that could just be implicit. That might be a reason to check if that namespace or if the service account exists in the namespace.
So we can only use service accounts in the same namespace.
Right. That's why. So anyone in the namespace who can create bucket accesses can grant access to any service account in the namespace. And that was sort of how we designed it, was that the namespace was the boundary.
And so that kind of implies that anyone with bucket access permissions to like create or modify a bucket access object is actually owner of the bucket.
Yes.
Because they can like create a bucket access.
They don't even have to.
It's the top of the hour, so I got to go.
Oh, Eric,
sorry, I have to drop. Thank you.
Then let's continue next week. Thank you, everyone.
Thank you.
Oh, hold on. So for the reviews, looks like you will need to update the cap again before you pin Tim, right?
Few changes, like about 5 minutes of changes.
And then also Michelle is also reviewing it, right? Michelle, you are reviewing the cap, right?
Yes.
Then you can also sync up with Tim. I think that'll be good if you know you have. Yeah.
I think I technically have more time than Tim.
Oh, okay. So maybe you can spend more time and then can give him an update.
Yeah.
That would be good. It'll be easier to find you since you are joining this meeting.
Yeah. I also have, like I say, I technically have more time than Tim, but also I'm finding myself pretty busy lately. So, but yeah, I will try to make an effort to take a look at the cap.
We really appreciate that. Thank you, Michelle.
Yeah. Okay. Thanks. Bye.
Thank you.
Thank you.